Welcome, statistics friends. We are on page 6 of your notes. We're going to start talking about hypothesis tests for proportions. I know one of my class did this in class, but that was before the world completely changed. So here we are, page 6. Ms. Gallus claims she is a 80% free throw shooter. She shoots 50 free throws and makes 32 of them. So the question is she exaggerating or is she actually an 80% free throw shooter? So our population is going to be all the free throws by Ms. Gallus. And from that, we're going to try and estimate the parameter of the true proportion that she makes. The sample we have is she's actually just going to shoot 50 free throws, which she did already. And the statistic we have from that p hat is 0.64. That's going to be the 32 out of 50. I'll come back to this in a second. There's two explanations for why she only made 64%. Either she's an 80% free throw shooter and had a bad day, or she's not and she's lying to us. So our null hypothesis here, H sub 0, is going to be that she is a 80% free throw shooter, so P equals 0.8. And our alternative hypothesis is that she is less than an 80% free throw shooter, and we have evidence towards that right here. So that's going to be our kind of claim there. In class, in one of my classes, we made spinners, and we actually simulated this. This is not the data they got, but it was a little different, probably a little bit decently spread there. Each of those dots down here, number 6, represents the percent of shots that were made by an actual 80% free throw shooter. So we had a spinner that had 8 out of 10 of the sections were made a basket, and then the other 2 were missing it. So when we got it, we got mostly above 60%, a lot around 80%, a few up in the 90s as well. But the 64% that Ms. Gallus got would be somewhere down here where it's not as likely to happen. If you do this a bunch of times, that percentage, that p-value of it occurring, 64% or less, is going to be about 1%. That's our p-value. And then because we got this p-value of all these simulations at about 1% compared to what we normally compare to about 5%, we do have convincing evidence that there's only about a 1% chance of an 80% shooter making 32 out of 50 free throws or less. So what we do here was we would reject the null hypothesis. We'd have enough evidence to reject the null hypothesis and go with our alternative hypothesis. On page 7, we have some notes to write down. So our hypotheses for proportions here. Our null hypothesis is going to be that our H sub 0 null hypothesis is going to be that P, the true proportion, is equal to whatever we're claiming. Our alternative hypothesis is going to be either P is not equal to, is P is less than, or P is greater than, like compared to our null hypothesis. And which one this will be depends on what evidence we have against it. Sometimes it'll tell us, sometimes we'll have to figure it out, and we'll go from there. The p-value, which we had on the previous page, that was the percentage that we got when we actually ran our simulation. So in that simulation, we were assuming that the null hypothesis was true. So in the previous simulation, we assumed that she was an 80% free throw shooter, and we got that p-value of about 1% probability of getting that 64%, that p-hat, or in this case lower, purely by chance. So because that didn't happen a lot, we were able to say either we fail to reject the null hypothesis and we kind of accept the null hypothesis, or we reject the null hypothesis based on whatever this p-value is compared to whatever this p-value is compared to 5%. In some cases it might be different, but generally we look at a alpha value significance level of 5%. So in our case, we had a p-value less than or equal to 5%, so we would reject the null hypothesis, saying that there is convincing statistical evidence against the null hypothesis, versus if we had something that was above 5%, we would fail to reject the null hypothesis. What I want you guys to do is read through application 8.1 here, and then I'll post underneath where this video is, I'll post the answer key to that so you can check.